Today's lesson is called Reflections, Day 1. This lesson is going to start with an investigation. So for this video, I'm actually going to explain the directions, have you pause the video while you complete the questions, then resume the video to go over the answers. So you are now going to answer questions 1 through 8 using the pictures to the left. So picture A and picture B. You can leave the other notation boxes blank. That will be filled in after the investigation along with me. So looking at those pictures, you are going to do some describing of what happened, what you're noticing, what you see. You'll be listing coordinates. I'll be asking you what happened. You'll refer back to the previous day's vocabulary and say what properties were preserved. You'll name the transformations, and then you'll compare picture B to picture A. So at this time, if you would pause the video, please, and try questions 1 through 8, then you can resume the video to check your work. Okay, now that you've answered questions 1 through 8, let's go over the answers together. So in number 1, if I'm looking at picture A first, it says, describe what happened from A, B, C, D to A prime, B prime, C prime, D prime. So when I look at that picture, I said the shape was flipped over the y-axis. It looks like it was picked up and flipped over that line. And the y-axis is this one. Now, other ways you could have said it would have maybe been mirror image through or over the y-axis. In number 2, it said list the coordinates of A, B, C, D, and A prime, B prime, C prime, D prime below. So the way I organized it is I listed them vertically, A, B, C, D, and then I put an arrow to show where that exact point lands on the other shape to help me, because I knew number 3, they were going to ask me about what happened to the coordinates. So you can see A was at negative 4, 7 and became A prime at 4, 7. B was negative 3, 4, became B primed at 3, 4. C was negative 5, 0, which became C primed 5, 0. And D was at negative 8, 3 and became D prime 8, 3. So when I look at these and I go to the coordinates and I try to see what has changed, I notice that this negative 4 became a positive 4. The 7 stayed the same. This negative 3 became a positive 3. The 4 stayed the same. Negative 5 became positive 5. Negative 8 became positive 8. So the x coordinate became the opposite of what it was. Now, I know in some instances, people will say it became positive, but we want to be careful of that, because what if it was originally positive? Then it would have become negative. So to cover both sides of the coin, you want to make sure you say the x coordinate is opposite. Then it doesn't matter if it's starting from a positive or a negative place, it's going to change its sign. So properties that were preserved. Remember that preserved means that it stayed the same. So I want to know what stayed the same from the beginning shape, A, B, C, D, to the second shape, A prime, B prime, C prime, D prime. So if you recall, orientation is the order of the points. So if I look at my original picture, A, B, C, D, is labeled in a clockwise order. When I look at the new shape, if I go in order alphabetically, A prime, B prime, C prime, D prime, A prime, it's labeled counterclockwise. So that did not stay the same. Orientation is the order of the points. So I did not write down orientation. The shape, however, did stay the same. The side lengths stayed the same, and the angle measure stayed the same. So to technically name that transformation, it would be a reflection. As you know from the previous lesson, a flip is a reflection. And because it was over the y-axis, that needs to be included in the description. So a reflection over the y-axis. Now, I wanted you in number 6 to compare picture B to picture A and say what you noticed. So hopefully you saw that picture B is a flip over the x-axis instead of the y-axis. So in number 7, I asked what happened to the coordinates from A, B, C, D to A prime, B prime, C prime, D prime. It did not specifically say you had to list all of the coordinates this time, but I still think it's a great strategy to figure out what's going on. So I just picked a couple. I picked A and B original points and wrote where they ended up. And this time I see that the x coordinate actually stayed the same, but the 7 became a -7, the 4 became a -4. So this time it was the y coordinate that became the opposite. And if I was technically going to name this transformation, it would be a reflection over the a reflection over the x-axis. So you have to say that it's a reflection. That's the technical name for a flip or mirror image. And you always have to tell me what line it reflected through or over. Now, one interesting thing happens in picture B that I'd like you to add to your notes. If we look at C and C primed, I don't see that it changed. So point C is actually the same as C prime. Why does this happen? Well, the line of reflection was actually the x-axis. So if I draw that in, point C was on the line of reflection, so it does not change location after the reflection. A nice way to remember this is opposites. So if I go back up, when we were reflecting over the y-axis, it was actually the x-coordinate that went to be the opposite. And vice versa, if I'm reflecting over the x-axis, it's actually the y-coordinate that becomes the opposite. So we're going to fill in the other notation now. This is another mathematical notation that could possibly be used to ask you to complete a reflection. So the lowercase r stands for reflection. It will either say y-axis or x-axis, so you know which axis you should be reflecting over. And then it tells you what happens to the coordinate. So remember, when we reflected over the y-axis, it was the x that became opposite. So you would write it as -x, y. That's what's going to happen to the actual coordinate. The coordinate was xy. You're going to change x to the opposite to get your new coordinate. For the x-axis, you're going to change the y value to the opposite. So this one will keep the x and the y will become the opposite of what it was. So now you're aware of the other mathematical notation you may run into. Now that we've investigated and discovered how these reflections work, we're going to go to the next page and actually create a reflection. So it says triangle ABC is shown plotted on the grid below. Its vertices have coordinates at A, 5, 8, B, 7, 3, and C, 2, 4. And as you can see on the coordinate grid there, it's already been graphed for us. So we have to reflect triangle ABC across the y-axis. So down here, I just want to make a little note. If I'm using the rule to do this, I would say, okay, I'm reflecting over the y-axis, so that means the x-coordinate becomes the opposite. So one option when creating a reflection is to know the rule and use the rule on the coordinate. So for example, let's look at coordinate A at 5, 8. I know it's reflecting over the y-axis, and I now know the rule for that means that the x becomes the opposite. So I can get the coordinate first and say A prime is going to be at the opposite of 5 is -5, and the y value stays the same, -5, 8. And then I can go over to my picture and plot the point -5, 8 if I want to. Now, before I do that, I want to talk to you about option 2. Option 2 would be to use the idea of what a reflection is, a flip or a mirror image, and count the grid boxes to help you find the location of the point. So yes, I could go take -5, 8 and plot it. We know how to do that. Let's look at the other option. If I find point A on the original shape, I'm going to count 1, 2, 3, 4, 5. It's 5 units away on the right of the y-axis. So as long as I stay on this same line here, if it's 5 away on this side, I'm going to count 1, 2, 3, 4, 5 away on the opposite side, and I'm going to plot that point. And that is my point, A prime. So either way, if I went to go do that back with green and I plotted the point -5, 8, it's still going to land in the same place. So it depends on what you prefer. If you're someone who likes to memorize the rules, we all need to know what happens to the coordinates. But when it comes to creating it, you can use the rule, or if you're a visual person, you can go to the graph and create your picture first and get the coordinates after. So let's do that with actually point B. B is on this line right here. It's 1, 2, 3, 4, 5, 6, 7 away on the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7 away on the left. And that point is going to be B prime. And so in this instance, if I go to the graph first, I can now come over here and write the coordinate after. So that would be at -7, B prime is at -7, 3. But when you look at the coordinate, you will see the rule in action because the 7 became -7. The x coordinate became the opposite. So let's go back and do the coordinate first this time. We had C at 2, 4. So C prime would be the opposite x coordinate, which would be -2, 4. So I would go to -2 up to 4, and there's C prime. But if I look at it from a point of counting the boxes and knowing what a reflection means, C was 2 away on the right, so it makes sense that C prime would be 2 away on the left when it's mirror imaged or flipped. Then we would take a straight edge ruler, connect our points to get our new image. Now we're going to connect each vertex of triangle ABC with its image point using a line segment. So I'm going to connect A to A prime, B to B prime, and C to C prime. So there are our segments. And it's asking us, what is the relationship between these segments and the y-axis, or the line of reflection? So I'm just going to kind of trace the y-axis in pink so we can see what's going on. And if you look at all these line segments, they've all been chopped in half, okay? And the pink line intersects it in such a way that it makes these right angles, right? Cuts it directly in half, completely vertically. So in this section, we're going to say the y-axis intersects the lines, and when they do that, they make 90-degree angles, and cuts the segments in half down the middle. So this is a helpful way to check your answer for a reflection. Pay attention to where your line of reflection is. If you were to connect the vertices of the original shape and the new shape, that line of reflection should cut those segments right in half down the middle. And if it doesn't, that means that we have not created a true, correct reflection. Okay, and then there's an image at last that we looked at the beginning, just to give you a real life situation of where we see reflections in the real world. And that concludes our lesson on reflections day 1.